We want to do a math lecture on a very important topic, algebraic processes. So we're looking at algebraic processes, and under these algebraic processes we look at the equations involving fractions. Then under those equations that involve fractions, we'll be paying a special attention to fractions with unknown in the denominator. So we have an example. We have to solve this equation. So solving this equation is simply to find the value of x for which this equation will be true. Here we set fractions with unknown in the denominator. So what we have here, the unknown is x, and this x is here the denominator. So this is what we want to study. We want to study this kind of fractional equations that has the unknown as the denominator. So that is where we are laying our emphasis in this lecture. So now, how do we solve this kind of problem? So first of all, we are looking at 1 over x is equals to 1 over 3. So how do you handle this? To handle this is to remove the fraction. How do you remove the fraction? You look at the denominators. So the denominator, we have two denominators here. We have x as the denominator. We have 3 as the denominator. So what we need to do is to find the LCM of that 2. So the LCM of the denominator of x and 3, you agree with me, is 3x. That is 3 times x. So that will give us 3x. So in order to remove that fraction, you multiply both sides by the LCM. So what we want to do is to multiply both sides by the LCM, which is 3x. So if that happens, you have 3x now times the first expression there, which is 1 over x. Then you go to the right hand side, the same thing happens. 3x, we multiply the term there, and what we have there is 1 over 3. So what happens here, you find out that x, we divide the x here. Then here, this 3, we cancel out 3 here. So on the left hand side, what do you have? You have 3 left. So you have 3 times 1 in particular. Then on the right hand side, you have x times 1. Then what is 3 times 1? 3 times 1 is 3. Then on the right hand side, what is x times 1? X times 1 is x. So what do we have? We have now that 3 is equals to x. So this is equivalent to saying that x is equals to 3. And that's what we have. So we have gotten the value of x for which we will substitute, and this statement will be true. So the first thing is just to clear the fraction, get the LCM, and use the LCM to multiply both sides of the equation. But there could be another method. There could be another way to clear the fraction other than getting the LCM. The emphasis is clearing the fraction by multiplying by the LCM. But there are some situations you can use another method. So let's look at another method we can use. So we are very much familiar with cross multiplication. Remember that cross multiplication, when you have a fraction on the left hand side, you have another fraction on the right hand side. For instance, if you have a over b on the left hand side, then on the right hand side you have something like c over d. So when you have a fraction of this form, cross multiplication is always possible. So this times this and this times this. So with that now, if you do this cross multiplication, what do you intend to achieve? What you achieve is to be able to remove this b and d, because that is the denominator that is causing the fraction. So if you multiply, this will give you a times d. Then on the right hand side, I have b times c. So a times d gives you ad. On the right hand side, I have bc. What have you done? You have cleared the fraction. So cross multiplication is another way of clearing fraction. But before you do that, the fraction must be of this form. Okay? So luckily enough, what we have is already on that form. So cross multiplication is very much possible. So what we can do is to say this times this and this times this. So if that happens, this will give us 1 times 3. Then here you have what? X times 1. So 1 times 3 is 3. X times x is x. So you have 3 is equals to x, which is the same thing as saying that x is equals to 3. Okay, so you see that this is even a quicker method. So all of them gears towards removing the fraction. So now we do a check. The question is this: if I put x here, if I put x equals to 3, will I get 1 over 3? That's what we mean by check. So we have to verify that. So that tells you that what you have done is correct. So the left hand side, what we have in the left hand side is simply 1 over x, and this will be equals to 1. What is x? X is 3. We put 3. And this 1 over 3 is exactly what you have on the right hand side. So now what do we have? We have therefore that the left hand side is equals to the right hand side. Therefore what we have calculated is perfectly in order. So that's how to check. Here in this example we have to solve this equation. So here you still have your y, which is unknown, as being the denominator. So what do? We are looking at 4 whole number 3 over 2 plus 1 over y being equals to 0. We have to solve this equation. What does it mean to solve this equation? It simply means to find the value of y. Okay, fine. So having said that, we first of all transform this into an improper fraction. So that's what we do. So this is a mixed number, so we have to convert it to improper fraction. To do that, it is 2 times 4, which is 8, plus 3, that will give us 11 over the fraction, which is the denominator 2, now plus 1 over y, everything still being equals to 0. So by the usual method, you find the LCM. So what do we need to do? We need to remove the fraction, and removing the fraction is simply taking away, finding a way of removing the denominator. So we have to remove this 2, we have to remove this y. So to do that, you use a technical method. So there's a technical way of removing that 2 and y. You cannot just delete it. So there must be a method of removing it. So what we do, the method is simply to get the LCM of that 2 terms. So we find the LCM of 2 and y. And what is the LCM of 2 and y? The LCM of 2 and y is simply 2 times y, which is 2y. So the next thing now is to multiply the left side and the right side by that LCM. So we're going to multiply each time by that LCM. So on the left hand side, you have 2y times 11 over 2 plus, so what we're going to do is going to multiply all these terms. We're going to multiply them by 2y. That's what we're doing. Okay, so we now have the same 2y times 1 over y. Then 0 is 0, but to show what we are doing, to show every details, let's say also 2y times 0. Okay, so that's fine now. So here we look at things that we cancel out. You see that 2 now, which is the denominator, we now cancel out this 2 here. So you have seen that we have removed the 2. Then here, that y that is also causing problem, this y we want to remove. You see how it's cancelling another y here. So it is gone. Then what do we have left? So what we have now is only y and 11. So we have y times 11 on the left hand side, plus here y cancels y, we have 2. So here you have 2 times 1. Then on the right hand side, any number multiplied by 0 is 0. Okay, so here we have y times 11 will give us 11y. Then here we have 2 times 1 will give us 2. So on the right hand side we still have our 0 there. So we collect like terms. Already the terms in y is already on the left hand side. So the numerical values remains on the right hand side. So in that order, 0 remains where it is and 2 comes over there to become minus 2. So we have 11y equals 0 minus 2. So now 0 minus 2 is the same thing as minus 2. So we see that 11y is equals to minus 2. But remember we are solving for y. So we divide by the coefficient of y, which is 11. So we divide here by 11. We divide here by 11. So here 11 will divide 11y, and you are left with y there. 11 will not divide anything, so we'll leave it in that form. So we now have that y is equals to minus 2 over 11. And this is actually what we are looking for. Now, but supposing you don't want to go there by the issue of finding the LCM, you see that you can transform this to be in such a way that you can do a cross multiplication. For instance, if you convert the mixed number to improper fraction, you had 11 over 2, then you have plus 1 over y equals to 0. You know, in this form, you will not do a cross multiplication, will not work out. So the only thing to do, you have to change few things. So if you transformed here, if you take this one to the other side of the equation, you have something like this. You have 11 over 2, then plus this one, the plus 1 over y coming over becomes 0 minus 1 over y. So if you do that, I have 11 over 2 is equals to minus 1 over y. So it is only at this point, it's now resembling a over b equals to c over d. So it is at this form now, it is possible to do your cross multiplication. So now, if that happens, so you now have 11 times y, 2 times minus 1. So you have 11 times y is equals to 2 times minus 1. So this will give you 11y is equals to minus 2. Then everything becomes easy as usual. So you follow the same normal process. So you are at this stage now. So you're more or less at this stage. So you divide by 11, or rather, you are at this particular stage. So you can always go by that method. So now the most important thing is that we have found the value of y that will satisfy the given equation. So now, to do a check, you have to check if actually, when you substitute y equals to minus 2 over 11 in this equation, whether it will give you 0. So if you put it on the left hand side and walk through it, will it give you 0? So that one is now left as an easy exercise.